In this video, we're going to talk about the difference between points, lines, segments, rays, angles, and stuff like that. So the first one is pretty straightforward, points. You know what a point is. That's a point. So we can call that point A, point B, point C, and so forth. Next, what is a line? If you're taking a geometry class, these are some basics that you want to understand. A line contains many points, and it extends infinitely in both directions. So it could have point A, point B, point C, and so forth. Now, you need to be able to name this particular line. So you can call it line AB, and for lines, you need to have both arrows to show that they extend in both directions. You can call it AC, you can call it line BC, you could also call it BA or line CA, and we could also say line CB. So as you can see, with this particular line that contains 3 points on it that's highlighted, there's 6 different ways in which you can name that line. So what about these 2 lines? How can we name it? The first line is simply called line L. That's it. Now the second line contains 2 points that are highlighted. So we could say it's line AB or line BA. So make sure you know how to name a line if you're taking a geometry course. Now the next thing we're going to talk about are segments. So what are segments and how do they differ from lines? So let me draw a picture. A segment contains 2 endpoints. It has a beginning and it has an end. A line goes on forever in both directions, but a segment, it has a finite length. So this can be called segment AB or segment BA. So as you can see, there are no arrows, so that tells you that it's a segment. If we put 2 arrows on it, then we have line AB. It's no longer a segment. But if you don't see those 2 arrows there, then it's a segment. So you need to be able to distinguish segments from lines, and in the next example, also from rays. So what is a ray in terms of geometry? And let's fix that Y. That Y does not look like a Y. A ray has features of a segment and a line. A ray has an endpoint and it has an arrow. That's a ray. So let's put some points on it. Let's call this point A, B, and C. So a ray has a beginning, which starts here, and it extends infinitely in the other direction. Whereas a line extends infinitely in both directions, a ray only extends infinitely in one direction. So point A is the endpoint. Now how can we name this particular ray? How can we call it? We can call it ray AB or ray AC. But we have to start at the endpoint. We can't call it ray BC because B is not the endpoint. So with a ray, there's only one arrow. A line has 2 arrows. A segment has no arrows. So if you see AB with 1 arrow, you know it's a ray. So here's a little matching quiz that I created that can help you distinguish rays, lines, segments, and points. So feel free to pause the video and match it accordingly. So let's start with number 1. So we see we have AB and we have an arrow that extends in both directions. So we have 2 arrows. That's a line. A line extends in both directions. So number 1 is B. So I'm going to highlight that in red. Number 2, notice that there are no arrows on BC. So that has to be a segment. And so number 2 corresponds to answer choice C. Now number 3 is not a line or anything. All we see is a dot. So therefore number 3 represents answer choice D, which is a point. And number 4, by default, has to be array. Array only contains one arrow as opposed to two. And so now you know how to distinguish a point from a line, from array, and from a segment.
Look at what is drawn on the whiteboard. It's a flat surface. A plane basically extends indefinitely in all directions. So if this surface extends indefinitely throughout, it will be a plane. This is just a part of a plane. A flat-screen television, a tablet, or a mobile phone are all examples of portions or parts of a plane. This football, on the other hand, is not a plane surface. But the important question is, how do we name a plane? The first thing we should know that a plane has infinite points on its surface. Say these 3 points are A, B, and C. This plane can be called ABC, but there is a catch. The 3 points we use to name the plane should not form a straight line. If we have a point D on the plane such that A, B, and D form a straight line, then this plane cannot be called ABD. Can it be called ADC? Of course, yes. It can be called ADC as A, D, and C do not form a straight line. It can also be named using single letters. If we write an M here, this can also be called plane M.
In this video, we will learn about parallel and skew lines. You might remember something about parallel lines from algebra. Parallel lines are 2 lines that never intersect. They also have to be in the same plane. So on this screen, these 2 lines are in the same plane, and if they never intersect, then they are parallel. The way we notate that 2 lines are parallel is with little arrows, like this. Because there's 1 arrow on each, it means that these 2 lines match and are parallel. This is especially convenient when we're looking at shapes that have parallel lines. For example, this shape is a parallelogram and has 2 pairs of parallel lines. The way we would notate that it's a parallelogram is to add in arrows. This set of arrows shows that the side on the left and the side on the right are parallel. And this set of arrows, now I'm using 2 arrows so those match up, shows that the side on top and the side on bottom are parallel. If you are referring to 2 lines being parallel in text and you need to know how to write that out in symbolic notation, this is how you do it. First, let's go back to these original 2 lines and label them with letters A, B, C, and D. So what if I wanted to say AB is parallel to CD? This is how you'd write that. You'd write your line AB with the line symbol on top, and then you put 2 bars like this. They look basically like parallel lines, and then CD. And the way you would read that is AB is parallel to CD. One interesting thing about parallel lines is that they hold or have a transitive property. What I mean is, if we have a first line, which is parallel to a second line, and this second line is parallel to a third line, then that means that all 3 of these lines are parallel. Another word that you should know is the word transversal. Anytime you have parallel lines and another line crosses them, like this, that crossing line is called a transversal because it cuts through the other parallel lines, the transversal. The last thing that we need to talk about is our skew lines. Now, skew lines are very similar to parallel lines. In fact, they are also lines that never intersect. However, Skew lines are in different planes, whereas parallel lines are always in the same plane. So to think about skew lines, we're going to think about a cube, because a cube lets us think about different planes. In a cube, each face represents a different plane. So I'm going to, in this cube, highlight two skew lines. The first line I'm going to highlight is this one. And of course, you could think about this line going on forever. And the second line I'm going to highlight is this one in the back. So these two lines are skew lines because they will never intersect if you were to extend them on forever. And they're also not in the same plane. So they're not technically parallel lines, they're called skew lines. So the things you need to remember are both skew lines and parallel lines never intersect, although parallel lines are in the same plane and skew lines are not in the same plane. Some other vocabulary and notation in text, this symbol is the symbol for parallel, and if we're notating it on our picture, we use little arrows matching to show that two lines are parallel. And the last thing is this transversal is a line that crosses parallel